Sometimes the hardest thing isn't doing the work, it's starting. If that sounds familiar, I want you to meet one little creature. This is a rat. Let's call him Johnny. Johnny lives at the University of Maryland inside a small laboratory cage. For most of his life, Johnny behaves exactly as you would expect. He eats, he drinks, he explores his environment. In other words, Johnny is perfectly normal. But one day scientists inject chemical into his brain, and something strange happens. Johnny doesn't become sick, his muscles still work, body is perfectly capable of moving. But he stops seeking, he stops walking toward food or water. Not because he can, but because he no longer initiates. The drive that once pushed him forward is gone. And that raises a very strange question. What exactly disappeared from Johnny's brain after the scientists intervened? You have probably been thinking the answer is dopamine, the so-called pleasure chemical. But if so, why didn't Johnny simply feel less happy? Why did he stop moving toward anything at all? Because dopamine isn't pleasure, it's pursuit. It's the signal that makes you move. And that signal comes from a very specific place in your brain. If you understand where it comes from, you might finally understand why habits control you. Dopamine doesn't just float around the brain randomly, it's produced deep inside your brain. Not in the thinking part, not in the emotional part, but in the small region of the midbrain. Two main structures create most of your dopamine. The Ventral Tegmental Area, often called VTA, and another structure called the Substantia Nigra. They are tiny, but they control a significant part of your behavior. From here, neurons stretch into other regions of the brain, like brain's own communications lines. One major pathway goes to the Nucleus Accumbens. This area is part of the brain's reward circuit. The Nucleus Accumbens does not create pleasure, but it creates drive. Second pathway goes to your prefrontal cortex. This is where decisions are made, like planning, self-control, or long-term thinking. And third pathway connects the basal ganglia. This is the system responsible for habit formation and automatic behavior. So what does that mean? It means dopamine connects desire, decision-making, and habits, not happiness. Knowing where dopamine travels is one thing, but when does it actually fire? Let's say I hand you a piece of chocolate. You might think dopamine spikes the moment you take the first bite, but that's not what happens. If I suddenly hand you a piece of chocolate, the dopamine response is actually quite small. But if I tell you the chocolate is coming, your brain starts to light up. And if you don't know exactly when it will arrive, if it could happen at any moment, the signal becomes even stronger. So why does our brain react this way? Because dopamine isn't responding to pleasure, it's responding to the possibilities that something valuable is about to happen. Deep in our midbrain, inside a small structure, our VTA, neurons are constantly scanning the future. Is something valuable about to happen? The moment the answer becomes maybe, those neurons fire. The signals travels to the Nucleus Accumbens, creating the urge to move toward whatever your brain believes could be rewarding. That's what dopamine is really doing. It's not creating pleasure, but it's creating the drive to pursue it. Once you understand how the system works, you start noticing something strange about this modern world. Big companies have learned how to use your own brain against you. Social media platforms are building their empires on one small structure deep inside our heads. Can you guess which one? Yes, you're right, the VTA. They understand something most people don't. Dopamine is triggered by anticipation, so they design for anticipation. Every scroll is uncertainty, every refresh is possibility. Maybe someone liked your post, maybe there is a message, maybe the next video will be even better. And maybe is exactly what your dopamine system is waiting for. That unpredictability pushes a powerful signal through the same pathway, VTA to Nucleus Accumbens. This signal is so powerful that it brings us to the real conflict. The prefrontal cortex, the most advanced part of our brain, is not built for the modern human lifestyle and its constant stimulation. It evolved in an environment very different from the one we live in today. It's built for the long-term goals, building something meaningful. And this dopamine system doesn't live in the future, it lives in anticipation. And long-term goals don't give you constant spikes. So the VTA fire less, and of course Nucleus Accumbens receive a much weaker signal. Which means there is nothing pulling us toward long-term goals the way bad habits do. At least there is no mechanism building into our brain that can fight that battle for us automatically. So in this case, discipline has to step in. That means the prefrontal cortex must override the easier circuits, those automatic behaviors that keep giving us a hard time. The price is obvious: energy and effort. That's why it feels heavy, not because you're weak. The reason is that your brain is wired to chase immediate uncertainty more than delayed certainty. Dopamine is not motivation itself, it's a modulator of effort. It increases the willingness to pursue something. But your prefrontal cortex decides the direction. If your environment is full of instant digital rewards and other easily accessible pleasures, your dopamine system will chase them. If you design your environment for long-term goals, dopamine will attach to those too. The system isn't broken, it's programmable. Understanding dopamine changes the way you see yourself. It isn't happiness or satisfaction, and it isn't motivation either. It's a signal, a small chemical signal from deep in your midbrain. For millions of years, that signal helped humans explore, build, and survive. But today the same system is being pulled in 1,000 different directions. Notifications, endless feeds, infinite scroll, a world built on artificial anticipation. And if you don't decide what your brain should pursue, something else will decide for you. Just like Johnny, when dopamine disappeared, he stopped seeking. But in our world, the opposite problem exists. The signal never stops. And if you don't choose where it leads you, you might spend your entire life chasing things that were never worth pursuing.